Okay, so welcome to everyone in my channel, the Geography Lab. So after so long time, I am going to making this video, and from now there will be a continuous video. Anyway, today the topic of the today discussion is how to generate high resolution digital elevation model. So in general, there are several digital elevation data that is basically these are basically the ESA-TM data, that is the space shuttle radar topography mission, and the raster DEM data. Okay, apart from these two data, we have the ALOS pulsar DEM data. So the highest resolution of the DEM data is for the ALOS pulsar DEM data. It is 12.5 meter, and the rest of these are belong to 30 or 90 meter DEM data. Okay, but in this video we are going to create the DEM data from the Google Earth engine, or sorry, Google Earth Pro. So our objective is to create a very high resolution DEM so that we can use for micro level elevation mapping. Because for say example, if I want to make a micro level digital elevation differences using these data, this could not be possible or even possible, but the representation could not be successful. Okay, so for this reason we have to generate the digital elevation model based on our primary input, or in other words manually you can generate this. Okay, so the Google Earth Pro is a very good alternative to generate the digital elevation data, and from this Google Earth Pro we can easily incorporate or export it to the QGIS interface or other interface, so we can produce the digital elevation raster data. Okay, anyway, so there are basically three successive stages for developing a day. First, we have to create some kind of a path which should uh, contain three type of dimension. First, x and y, and associated z. That means if we want to create one path, and each and every path should have some kind or some sort of vertices or the nodes, and each nodes is dedicated to three type of information, that is the latitude, longitude, as well as the elevation, that is the x, y, z. So in order to create the path, okay, so this is my one kind of case studies area, because I am choosing this studies area because it is the area where we have a great altitudinal differences, so we can easily visualize our result. Okay, anyway, so for creating the part we have to go to this button, that is the add path button. So after clicking the add path button, you just keep it aside and just draw irregular path. Okay, so it is, keep in mind this, there is no such kind of rule of thumb to generating the path, but one main thing is that you have to maintain the entire area equally. That means the distribution of the random path should be equally distributed over the pace. For example, if I want to create this kind of area, for example this square shape area, so my distribution of the path should be equally spreaded in between this region. Okay, so in this way we can generate, or we can fill this zone using as much as nodes or vertex using the add path option. Anyway, for showing the this tutorial, I am just covering or just draw the this amount of the path with this amount of nodes. Okay, anyway, I am giving this name is simply DEM KML and okay, so my path is saved here. Now keep in mind it's this, we have to save this file as KML file. Okay, it is very important, not KMZ. We have to save it as KML file. So now just create one folder in desktop, that is the DEM, and our file is saved there. Okay, anyway, so then our first step is done actually. So we have successfully created the digital elevation, the path for creating the digital elevation model. Now our second step is to go to this specific website, that is the gpsvisualizer.com/elevation. So here we have to generate the DEM database, because through this path we have x and y values corresponding to these nodes or vertices, but we did not able to capture the z dimension, that is the elevation dimension. So for that we have to assign the elevation data corresponding to these nodes. So for that we need to take this help from the GPS visualizer. Anyway, so from here you have to upload the file and just go to the specific folder, upload the KML file and open. Okay, so now after the uploading you have to click this button, that is the convert and add elevation. Okay, just clicking this point, and after fifth time it will give one GPX file link which can contain the x, y and z dimension. So if you click this link you will be able to download this and save it in the specific folder, and I am keeping the name as it is. Okay, so our second step is done. Now our third step is to go to the TCX converter. Okay, so it is one kind of software where we can convert the different kind of GIS or GPS based file into another format. Okay, so here are the some some accepted formats represented here. Okay, anyway, so now we have to open the same file we just created. Let me go to the file and make sure to upload the GPX file, because we have the corresponding, we already attached the elevation data to this GPX file. Now open the GPX file, and after this opening it will automatically progress and you will see the altitude. This is the altitude, that is the elevation data corresponding to each lat long. Okay, so after completing the conversion process, we have to save this file as a CSV file. Okay, so I am saving a CSV file and given the name as DEM CSV and save, and make sure that we don't need any kind of the separation. So I am going to use the no, because we don't need any kind of the separation. Okay, so now our CSV file has been saved. Okay, now the last step is to go to the QGIS software. Now we are going to add this CSV file into this QGIS interface. So for that we have to go to the layer button and then go to the add layer, and from here we need to click the add delimited text layer. Okay, because through this button we can add the we can add the CSV file. Now click here and choose the file. So here's the DEM, and CSV file is that this is the DEM CSV. And after that you will see the the sample of the data here. Okay, anyway, so now you have to assign the lat, long and altitude values. Okay, so latitude value should given to the y-axis, because latitudinal are actually increasing by following the or along the y-axis, and longitude following the x-axis. Okay, and the z field should be the all the altitude version. Okay, and make sure to keep it geometry as EPSG 4326 WGS 84. So this is the global geographic coordinate projection system following the World Geodetic Survey 1984. Okay, now I am going to add the point. Okay, now you can see our points have been added in the QGIS interface. Now the next thing is to save this point as save file. So for that you have to right click here and export and save features as save file, and give the file name to the specific folder. I am giving name as point DEM. Okay, now let's keep it as like that, or maybe we can change the projection system here, so we don't need to do the reprojection, because for creating the DEM we need to do the reprojection data. Okay, anyway, in advance we can convert the projection system here also. So the UTM projection system is 43 north in this case. Okay, so it was earlier in the geographic coordinate system, that is the EPSG 432684. Now I am converting to the projected coordinate system, that is UTM zone number 43 north. Okay, that is EPSG 32643. Anyway, just okay, and it will automatically added the point here. Just make sure to check the properties to see whether the projection system has been changed or not. Okay, the projection system has been changed and the unit is meter. Okay, so you have to keep in mind. But if you see the earlier version, that is DEM, the projection in the unit is the degree. Okay, so that means it was in the geographic coordinate system. So make sure to convert this data to projected coordinate system. Okay, so the next thing is to do some kind of interpolation based on the altitude data. Okay, so if you open the attribute table, so we have the altitude column here. So these information are actually the elevation data corresponding to each point. Okay, we have to go to the processing toolbox and search for IDW interpolation. Okay, so here we will find this is the base function, that is the IDW interpolation, and just click here and put the the point DEM. This is the input layer, and choose the altitude as a criteria for the interpolation, and make sure to specific these input layers. That means that how we actually want to do the interpolation. Okay, so for that you have to just click the plus button, and automatically it will create, or it will add the available vector layer into the input layer. Okay, so for that we have just created the point DEM, and altitude is the attribute, and now we have to select the which type of interpolation we are actually wanted. So for that now we are going to add the structure line, because we are we want to create the contour on the basis of the output raster. Okay, so for that the default coefficient, the distance coefficient is 2.0, so I will keep it as a default. Okay, the extent should be the extent of point DEM, because I want to create the raster with the same extent of point DEM, and make sure to increase the cell size because it is 0.10 meter, so it is very high resolution cell size, so it will take so much time. So here I am going to hit 1000 as for example, and now click the run button. Okay, so after clicking the run button, it will generate the DEM, and if you want to make 30 meter, 40 meters or less than 30 meters, you will create as 10 meter, 20 meter. Anyway, whatever you need, you can do this kind of basic resolution by adjusting the numbers here. Okay, so but it will take so much time. For example, if we give the 10 meter resolution, then it will take around 20 minutes to generate the result. So that's why I'm giving the 1000 meter resolution. That's why I have the result in a few of seconds. Okay, so anyway, this is the 100 meter resolution interpreted raster DEM, but I already created the 30 meter resolution raster DEM here. Okay, so if we, after creating the raster DEM, for visualization, you just before visualization, or maybe you have to just save the raster as save layer as and as a TIFF file. Okay, from here you will can able to save the result. Okay, so let me save here DEM 1000 meter. Okay, so rest of the things will be unchanged. Let's hit the OK, and it is our newly created DEM layer. Okay, so now if I want to visualize the data, so go to the properties and symbologies, and then from here we have to choose the single band pseudo colors, and from here we have to choose the correct color ramp. Anyway, we can plasma is another option. Anyway, so continuous, maybe you can choose the equal interval, and class will be 5, and just hit the classify. Okay, so now our created DEM is look like that. Okay, but we want to create the contour line also, which will be overlapping on the area, over the area. Okay, so for that you just have to create the search the contour, and then you will find the contour from raster under the white box toolbox. Okay, so white box tools is another add-in which I will show how to add in the QGIS in next and upcoming video. So so from here you have to choose the function, that is the contour from rasters. Okay, once you choose, you automatically have the raster data on the basis of which you are going to create the contour. And here I am keeping the for example 250 meter contour interval, and rest of the things I am keeping it as default, and just hit the OK. So now you see our contour is generated. So this is the output contour. So just before doing anything, I am going to save this contour and as a save file, and name as dev contour 1000 meter. Okay, so hit OK. So this is the newly generated contour. Just remove this file from here. Okay, now if we see the attribute table, we will see the height value. Okay, so now I am just going to create the or change the color for better visualization. Okay, so I am making it as black. Okay, so this is the DEM line, and I wanted also add the labels of the heights. Okay, so again go to the properties and go to the labels, and from here you have to select the single labels, and from here you have to seek the height value. Okay, and then apply. So now you will see that the contour line and corresponding height. Okay, so from here you can easily make a beautiful DEM map from the Google Earth engine, as well as the contour lines also. Okay, so anyway, here is another example I just created on the basis of the DEM, but the resolution is quite high. So now you will see how it will look if we increase the spatial resolution from 1000 meter to, for example, 30 meter or 10 meter. Okay, so if you need better resolution DEM, then during the raster creation you will add the higher pixel resolution value, so that's why you can have a better resolution DEM. Okay, so apart from that, what I am wanted to do, I just click of the DEM. Now I have the contour value. Now I want to visualize whether our data is correctly overlapped over the base map. Okay, so for that I am going to use the open layer plugins or maybe quick map service. Anyway you can use. So from here I am going to add for example S3 and S3 physical. Let's see what happened. So anyway, this, I think this layer is not available. Just remove this layer. Again I am going to add the open layer plugins, and from OpenStreetMap, and from here going to add the OpenStreetMap. Okay, so now you will see how our generated contour are actually overlapping with the base map. Okay, so just I am going to reduce the transparency to 50% for better visualization. Apply, and now you will see the DEM values as well as the contours which is just overlapping with each other. Okay, so for example, if we want to see the river valleys, okay, you will see it is the the plain surface is this side. It is the lower zone. This is the plain surface where we have the several towns and settlements like things, and these are the very high altitudinal areas. Okay, so this is the complete guide how do you actually create the digital elevation data with the help of Google Earth by using the TCX converter and also the QGIS. Okay, so anyway, thank you for watching this video, and make sure to subscribe the channel.